Okay, so we're now going to define a function called isAlive in AnyLogic. So first of all, we can drag this function in here. Really, these should be lined up. So we'll have isAlive. Now, I've been really sloppy in this. I named a bunch of functions with capitalized letters. I really should have given, I mean, by Java conventions, you should be lowercase. It's very bad. And sometime I'll go back and sort of clean that up probably pretty soon. Now that I know that someone's actually looking at this.
I never would have known.
So it's a little bit embarrassing, but it's very very good to know someone actually cares out there. Okay, so here we want to ask if they are alive or not. Now, how are we going to determine if they're alive? Well, there's a state of death. See that right there? Yeah. Right. Here in isAlive, we need to actually say they're not in that state. Okay. So what would I do to say, are they in that state of death? Okay, good. And who would I have to ask if the state is active? State chart. Infection state chart, in case you can't see up here. And then I have to do is state active, and then I can do person.death. By the way, person is not needed here, technically, because I'm inside a person. But as I said, it's good practice. Okay, so this is isAlive. So can I just return this? No, I have to the opposite of it, the not of that. Okay. Now, what is this going to return as a function? What is it going to return? Is it going to return an integer or double, a string, a void? It'll be a Boolean, true or false. Yeah. By the way, Java's convention, when you return a Boolean, you like to say is X. Like is a child, or is an adult, or is male, or is pregnant, or whatever. Okay, so that's isAlive there.
It's really obvious here that
Yeah.
it's easiest to say it's not dead, but sometimes if you get a more complicated situation,
Yeah.
you might want to look at the opposite. Would you just say is susceptible or is infected?
Exactly. So I can create an isAlive and isDead if I wanted to as methods. Alternatively, I could create I could do is susceptible or
Define a life based on that or that.
right. Exactly. Yes, I could, but generally to spare the user the need to think in complexity, I could actually define quite a few useful functions that would then be used in many places, and they don't have to worry about how the state charts look and whether you have multiple state charts or just one state chart and all that sort of stuff. So
And then could you, if you had a statistic later, could you call on that function you just made to report how many people are alive?
exactly.
Okay, so that would,
Yeah, that's exactly what I do. So let's do that, okay? So how would I use this function? I just added this function isAlive. Where would I put a statistic based in it to count? It would be the population, yeah, it would be up in Maine, right? And here, pop. Okay, there we go. And put in statistics. And then add statistics. And we do sort of count alive, right? And what would we put here? Item dot nope. No, it turns no. Well, we're not gonna ask about the state chart now that we created that. What can we do?
what would you start the function?
Just do that. It's much cleaner. What's that? No, because this is actually, is this a statement or an expression? It's a expression, it computes a value. So we don't actually need a semicolon. Instead, the semicolons are needed for statements, but not for expression. So it's a great question, but we don't need it. Okay, so let's go look here. So if we were to run this, here we go. Okay, and whoa. Okay. Oh man. Okay. Kind of any logic overload here. Okay, so infection stat, here's the alive count, 6139. So, frankly, a lot of what we did in the boot camp with that statistics and putting that condition in there, much better putting functions. So if you don't, unless you have some real strong reason for not putting a function, just create a function for those things. It'll just make it much more clean. Then when you look at the statistic, it's more obvious that it's correct. I mean, people's eyes glaze over when you just show them like long things, long statements, long expressions there for computing things. This is just much easier to read than something like this. And it's much less fragile, as I said. If how we keep track of aliveness changes, maybe we have a Boolean variable, we can, then we can just update this. We don't have to worry this. We just have to update the method, and we don't have to worry that we have to go throughout the model and fix those sort of things. Does that make sense? Okay. So that's an example of a little method that's that is conceptually simple. It doesn't require a parameter. Let's look at one that does require a parameter. Okay, so here's one that takes a parameter. Color for relation. Okay, what does this return? What sort of information does this return? So remember, functions can compute so that they can return a value, or they can do something, perform some action. Sometimes they do both, although it's better to have it either do one or the other. If they do something only, what do they return here? They return void, right? Here, what is it returning? What sort of thing? Color. Now, what sort of thing is it taking to do its job? To do its job, there's this thing called function arguments. Argument here is used sometimes in a way close to meaning parameter. So this is information passed to the function to do its job. So what does it need to do its job? It needs something passed to it that's of type reference to a person, and it's called other person on connection. So here, what this function is doing is it's actually saying, okay, you're connected with, tell me the color to use when you're connected with this certain other person. And you'll see what it's going to do is, for the connection to the mother, if this other person on the connection is the mother, then it will turn red. It'll say use red, otherwise it says use black. So it's kind of like me, so where this would be used, for example, is if in person you have to connect together the, if you have to connect together, for example, a person with other people. So if we have here, for example, this line here, and we want to look at dynamic properties for this line, we might color it differently based on who they're connected to. So if it's connecting, so if the person they're connected to on this line is their mother, then it will be red, otherwise it will be black. Does that make sense? So if we run this, by the way, so let's look at this code. Let's try to piece out this code. This is a somewhat more advanced code. So here we have a line color argument. Do you remember this thing earlier? Oh. Okay, so this is the one we want to understand, the line color one. But do you remember this dx one? Do you remember what index was here? If you put your mouse in here, it'll tell you. This is the index of the line. In other words, remember we have the line. If I'm connected with 3 people, the line has to be copied how many times? 3 times. And index tells me is it line 0, line 1, or line 2. Okay? So this line color down here, this get connected agent, that's the person to whom I'm connected on that line. And I take that and I say, hey, for this line color, I want to figure out what color it should be. I give this function. The function job in life is to be given a reference to the person on the other side of this connection, and it will return information what color to make that line. And the rule is, if this is my mother, color it red. Otherwise, color it black. Does that make sense? So it's going to color it either red or black, depending on whether this other person I'm connected to is my mother. So if it's my mother, it'll be red. Otherwise, it'll be black. This is a function. You give it this information about who you're connected to, and it says, that person, you're red. That person, you're black. It should be black.
So get connected to agent.
Yeah.
Is that a function that's just built within AnyLogic that they set up?
Yeah. It's a function that they set up. And watch this. You may be wondering why you get this person thing. So get connected agent. Well, okay, so let me do it out here so I can see the definition of it. Get connected agent. See, it returns an agent, so-called agent connected to D. Wow. It's actually returning not. It doesn't know to return a person. This is what we were talking about yesterday. That AnyLogic wrote this. Who knows when they created it? 5 years ago. They didn't know we'd have a model with person in it. They didn't know we'd have a model with deer in it. They didn't know we'd have a model with elk in it. They didn't know we'd have a model with antelope in it. So their get connected agent just returns a reference to an agent. Now, to an agent in general, in a generic way. Now, person, in fact, is an agent. We'll get to that in a little bit. Person is an agent. So we could say, look, I know this is to a person. The only things people are connected to are a person. So it says basically treat this as a person, and it'll blow up if it's not. But in this case, it's always safe to do that. And that allows us to pass sort of whoever we're connected to as a person to color for relation. So this get connected agent, that's something they defined for our use. Does that make sense? And we just say, hey, look, I really know this is a person. They defined it in a generic way. This returns to an agent, but person is an agent, a deer will be an agent, an elk will be an agent, an antelope will be an agent, a Brevi zebra will be an agent. So they're all agents. And so if we know in our model we have persons, we could just say this is a person. Now, it would start to get more messy if in the same network we had persons connected to dogs or something like that. But in this case, it's all persons with persons. And later, in AnyLogic 7, you'll have separate networks, presumably for your dog network, your pet network versus your other humans types of connections. So this is how that's used, and that thing will then allow us to distinguish males and females. So, connections from other connections. So let's take a look at this. So if we were to run this, and we were to stop the model here, we should have, okay, babies being born here. Whoa, whoa. Okay, well, let's run this model. Let's speed it up. Okay. This is not a foremost. This model is not distinguished by its user interface. Let's go through. Let's find someone whose mother is around. Let's see. Is there? Okay. So what's going on with their mother? Why is that grayed out? That seems to me kind of curious. Okay. Let's actually go look at. So there's, I think, 10,000 people in the population. Let's go look at some of the later people who were probably born more recently. Yes, so 10,500. Let's look at someone at 10,000. Okay. Still no information on their mother. I'm not sure if that was because. Oh, there we are. Okay, and you'll notice. Do you see there's a red line here? What do you think that's the line to? The line to the mother. A hotline to mom. Just right there. So that's why that's red. It's because that little method that was color for relation, that little method turned red for that particular connection. It said if this is a connection to my mom, color it red, otherwise color it black. Does that make sense? Okay, so that needed some information about who am I connected with. So that's an example of a function that needs some information to do its job. Let's look at a little bit more about this, and we'll talk about this sort of subclass and subtyping thing as well. Okay, so this is a function called perform birth. Okay, this does some work. It accomplishes something. It returns nothing. So let's look at the code for this. Okay, can anyone help me understand what's going on in this code? It's not? So I guess the question is, first of all, is it taking any arguments? It's returning nothing. It's not taking any arguments. It doesn't require anything to do its job. But what happens here? There's a bit of code here. I'd like you to help me piece it out. Oh, I should have stopped.